Now we just go ahead and get started. Today we're very happy to have Professor Michele Bodrin to give us a seminar. As I guess all of you know that the Professor Michele Bodrin is visiting us in the past 2 weeks. In fact, he also very kind enough to also give 2 guest lectures for my PhD course on top economic growth. And I think that some of you probably have been aware that Professor Bodrin's work is closely related to our new structural economics. I believe that today his presentation also going to present a model closely related to this technology between capital and labor switch and substitutability. And you all see his bio. He's a world-famous macroeconomist, so I guess I want to save time for Professor Bodrin's talk instead of giving a long kind of introduction. He has a lot of honors, etc. So without further ado, please join me in welcoming Professor Bodrin.
So thanks, Wang Yong, for the presentation, everybody for the invitation, including Jianxing Yifu Lin, that is not here, but
he's
I
in
had the
Shenzhen.
pleasure of meeting in Shenzhen working. We all have to work. And it was a very pleasant 2 weeks. I think we started a number of interesting cooperations, so I hope we can continue. In fact, because of that, the paper I'm presenting is not the paper I had in mind to present. This I digged out from old work with David Levine. I was planning to present something about monetary theory, banking, and so on. We'll do it next time. This is actually a very old paper. You have the paper in front. You can see that the first draft is 12 years ago, which was pretty much, this is about the last thing I wrote together with David after a period of about 10 years in which we wrote maybe 20 papers on competitive innovation. I kind of dropped that stuff. It didn't seem to convince the profession that the way we study growth and innovation is off the track. I keep believing it's grossly off the track and has explained pretty much nothing of what has been happening in human history. But then again, people get convinced to go off the cliff. You don't have to keep fighting. You might as well dedicate yourself to other activities, which is what I've done. But in conversation here with colleagues, and Wang Yong in particular, I said, well, people here seem to have a different point of view on the stuff. So I thought, well, I have this old project with David, which I like very much. Let me dig it out and rewrite it a bit, which I did in these days. So this is a version different from the one that circulated, and present it to the people at the Institute and the Peking University. So maybe I get comments that I may improve. So what's the goal of the project? It's something that I've been thinking all my professional life. I am essentially a Schumpeterian, old-fashioned, or in one article I wrote, which I should have circulated here, I'm actually a Marxist from that point of view. In fact, I wrote a kind of ironic article, not so ironic, but provocative, years ago, published in a British journal, titled Growth and Cycle in the Mode of Marx and Schumpeter. Because this is actually the bit of the mode of Marx and Schumpeter in the analytical sense. And so what's the idea? The idea is that growth cycles are an endogenous feature of market economy where market has to be interpreted in a very extensive way. Obviously, in the analytical representation, for a variety of reasons that we all know, I assume perfect competition and so on, but it's fairly irrelevant. The fact that something may happen in perfect competition doesn't exclude that in reality it happens also under conditions other than competition. It simply points out that probably the driving force for this something, in this case growth and cycle, to happen are fairly independent from market structure and are due to other forces that you may find under competitive market structure, monopolistic market structure, a mixed economy like clearly China is, and in fact like Most economies in the world are. There's no economy that is perfect competition. Even the economy of Hong Kong or Singapore or United States, which are probably more open to competition and less state intervention than other, are clearly economies in which government controls 20, 30, 40% of GNP and have a lot of legal presence into regulations on. That's certainly not like the idealized economy I'll be presenting you in a moment. And those in the past, the 17th century, 18th century, 15th century, certainly were not. That's not the issue. The issue is not to advocate that, competition used here is the key thing or is the realistic framework. The key is to try to abstract from those aspects of reality, and there are so many hundreds, as every good economist knows, that you deem not so important or even irrelevant for the phenomenon at hand, and try to think what are the features of the phenomenon at hand that actually may explain it or are the main driving force behind it across time and space. And so the view is that most economies have grown in cycles. There is no such a thing as balanced growth. There's not such a thing even as remotely balanced growth. Not only because sectoral composition, factor price, factor share keep changing, but also because there seems to be a certain regularity in market economies and not that economies either they stagnate for a good long time. I don't think I need to give examples. Right? So economies either they stagnate sometimes for centuries, all right? Or when they grow, in the sense that income grow and there is capital accumulation, there is innovation, they don't do it at a quiet, steady, tranquil pace. They do it in waves. Now, obviously, a lot of macroeconomic research, in some sense, all of macroeconomic research during the last century, and unfortunately, certainly since the Great Depression, has decided that the two phenomena can be separated. Then we can study the so-called trend, right? Separately from the business cycle, that is separately from the oscillation in growth rate and employment level and investment activity. And that, in fact, that's the right way to do. In fact, we detrend our time series. We even have invented more sophisticated tools. And I'm not trying to put down those tools. They're relevant sometimes. But we automatically use those tools to eliminate trend and look only at the cyclical component using analogies from Fourier time series and so on. Those are all useful tools. I just don't think that it's appropriate when you look at the growth process and its interaction with cycle. I keep thinking the old idea that Schumpeter had, that the phenomenon of growth is a phenomenon due to a continuous entrepreneurial innovative activity. That entrepreneurial innovative activity does not come from the sky. It may come from R&D. It's a very recent phenomenon of the thing called R&D. It comes from the continuous effort to make money, to get a profit, to get more out of your inputs, all right? If I were strictly a Marxist from the philosophical point of view, it says from trying to exploit your inputs, not just labor, land, energy, and whatever not. Where exploit means if I get more stuff out of what I use and purchase, I'm better off, okay? And obviously the intensity with which you do so, the amount of effort you try to put in doing new things to exploit inputs better is proportional to the payoff. That's one thing that we're trying to capture here. So competition here has this function. And we use perfect competition because it's very simple analytically and it gets right to the point, right? If I wanted to study other social phenomena, I would probably put bargaining function and fighting and social conflict between one type of workers and the other, between capital holders and rentiers, and so on. But that's not my concern in this moment. In this moment, my point is to simply say, look, people try to innovate, that is, get out of the routine and do something new and costly and risky. Innovation is always risky, right? And therefore always costlier than the other thing. Because they see that there is a payoff. Because by repeating the routine, you're getting nowhere. Because your output is not increasing. Because some factors are running out of stock and they're no longer available. Because they're going somewhere else and they're becoming costly. Because the sheikhs raise the oil price, what not? Okay? So that's the story I'm trying to tell. Modeling growth and innovation under competition. Obviously, there is a side effect. That's why this was done with David 12 years ago. At that time, we were trying to dispel what we keep believing being an erroneous conviction. That is that the innovative activity, the creation of new technology, is the product of some kind of increasing returns phenomenon that requires as a precondition some form of monopoly power due to some fixed cost in the creation of ideas and innovation. The model speaks to that too, and I will get to that point at the end. So there was that point. It says, no, absolutely not. It's not true that in order to have technological innovation, creation, new technology, you need all those strange conditions. In fact, you might easily have it under perfect competition. So from an analytical point of view, either circumstances may yield innovation. Which one does, in reality, it's an empirical matter. I tend to believe the facts and history and data suggest that, in fact, there's a lot more innovation, technological progress and growth in factor productivity under condition of competition than not under condition of monopoly or state regulation and so on. But it's an empirical matter. And it should be debated and treated and decided empirically with facts. As a theoretical point, the two both have arguments in favor and stand their own ground. Okay? So that's one side effect of this paper. But today I'll focus more on this, right? On the endogeneity of cycles of growth. And the way it will be obtained is through a dynamic process of sequential innovation, which, interestingly enough, as you will see, there are no fixed costs in the model. In the paper, there is an appendix. We actually handle technically the fixed costs. That appendix I not had time to change, so it's still the old version. There might be, I know it's got some very complicated formula. David was marvelously efficient at that. At a certain point, the formula was so long, I said, oh, hell with that. And him being the side guy that he is, said, no way, I'm going to figure this out. And he did. All right, so honor to Professor Levine, Caterpillar style, as usual. But so that appendix I will not debate with you. It's here in the slides, but there is an interruption before that because I don't want to run the risk of boring the audience with complicated action. Okay, but there will be a surprise, and you will see it right away. Okay, now in terms of data, what is that we have in mind? Let me show you two data, one micro and one macro. So you can collect a lot of evidence. So this is actually RAMs, type of RAMs. And as you notice, actually, this is old data. We were not. This is a good evidence of laziness or lack of a dedicated array. But these are the waves generation of different generation of RAMs and how one gets replaced by the other and how production ramp up and go down. Okay, so you can find plenty of that at the micro level when a certain product or class of products can be properly and unambiguously classified as type 1, type 2, type 3, where you know the type 3 is better than type 2, and type 2 is better than type 1, and there is some degree of increase in productivity. So that's a stylized fact you will see our model reproduce. This is actually the grandiose project, and actually with Wang Yang and LJ, Xu, Lijun, we're trying to work on this as well. But this is a motivating thing that I have in mind when I talk about the growth society. So what do we have here? Well, let's start from that thing. This is the real gross national product per capita of the United States. So it's per capita because in the model I'm thinking of a stationary economy with, well, stationary not, but with a constant population. you can see that it grows in fairly regular waves, and then the waves, oh, wonderful, are characterized by these recession periods in which output either decreases a bit or goes flat. Seeing or not seeing the decrease is often a matter of the frequency at which you measure the data. When you measure data annually, these are measured quarterly, many decreases disappear because at the annual level the output actually does not disappear. Which is why I think before I said, the cyclical, the frequencies at which we look at data is relevant because it contains information. It depends on the question you're asking. That's why I wasn't trying to put down, all kind of cyclical analysis. At a monthly level or a quarterly level, there are movements out there that may be relevant for an economist to understand, not just for policy purposes, but for purely scientific purposes. Okay? If you want, I'm more interested in the annual frequency. I kept everything quarterly just to have the opportunity of saying this. But, the way I like to think of this is annual. So the way it grows, stylized, goes up, and it goes flat. It goes up, it goes flat. And obviously the distance between an up and a flat, which in the model being ultra stylized will be regular, here or not. Sometimes there are very many consecutive flats, like over there, here. Sometimes the up lasts a long time, okay, like the last one. Here is employment. If you notice, employment does pretty much the same thing. That's the red line, as output per capita. It's remarkable. This distance between the two, though, these are index numbers. So the distance between the two tells you what? Tells you that there is a fairly regular, on average, growth in productivity. The idea of TFP comes from there, right?
Right.
If I look at the variation of this, the variation of this, and the variation of that, right? But in particular this over that, I say labor productivity is increasing. And then the question you ask is the distance between these two completely captured by the variation of that? That is labor productivity increasing only because there is more capital of the same type? We know that the empirical answer at this point extremely strong, and that was the big innovation of Solow and many researchers in the 50s, is no. But actually, it's very funny. Allow me, that's one reason why I'm a fan of Schumpeter. I know that people quote the classics and don't read them. This doesn't apply to this audience. I'm sure that here everybody has read quite carefully both Solow 1956 and Schumpeter 1911 books on the theory of economic development. In fact, I'm sure that everybody here knows what footnote 6 in Solow 1956 says, right? No.
Yeah, I think too
Read
flattering, no. Sorry.
Now you do.
Yeah, now I do. Yeah.
And why am I saying that? Because good old Schumpeter starts out the theory of economic development with an observation that, in fact, Solow then turned into numbers half a century later. Literally. Because he says, look, it's true, we had growth in this stuff. Right? And matter of fact, it says, sometimes it even grew fast in the past, like 0.1% a year. In recent years, the book is written at the beginning of the 20th century, it says it's growing a bit faster. Sometimes even 0.5, 0.8%, or 1% a year. And in fact, this is marvelous. It says many people think it's due to this. What's this? That's the capital stock.
Yeah. Top one.
Is it? Yes. Capital stock at constant national prices. Another evidence you see that there's not much balanced growth because the capital labor ratio, as you notice, is changing dramatically. Right? It says that most people like to think that this blue line moves up because the purple line moves up and it's just due to saving. It says, in fact, the standard model he calls the model of equilibrium at the time, and what he has in mind is it's very interesting. The guy is really very smart because it's 1911 that he publishes the book. So probably the stuff has been written in the early years before that. This is not so long after Varra writes the linear equations. It's a bit of research in the German-speaking world, Ben-Baberg and so on. But certainly doesn't have a linear model of production, nor a Cobb-Douglas or any or CS in front. CS was formalized in the 60s, half a century after. But he more or less guesses right. He said, in a world with constant technology and so on, if this goes up and then population goes up, that thing will go up more or less steadily. And he calls that equilibrium. Okay? Jesus, I'm going to hurt myself before I finish. I better remember that this thing pops out. He says, but that's not the reason why we've become richer. If we think that it's just saving at constant technology that we just become more capital intensive, and think again. He says it's obvious that if you look at those situations in which there is true technological stagnation, but there is a little bit of saving and accumulation, you don't go very far. Yeah, those economies got a little bit better over time, but it took some time, half a century for income to just grow maybe 10, 15%. None of that. It has to do with the fact that we change machines. He said we have got all, and he introduces he's introducing TFP. He's just saying exactly what then Solo's regression and the other people and Grilliges and all that work done in the late 50s showed empirically. That if I try to explain the movement of the blue line, the growth rate of the blue line, period by period, with movements in the pure dollar value of the purple line, and whatever measurement you have, doesn't matter, hours or bodies, of the red line, no matter which weight you put there, they put factor share, but we know that you can combine with other reasonable weights, the result doesn't change much. No way you get the explanation of the blue line. The blue line grows for a century and a half now, much more than that. And that we call TFP, which is what Schumpeter said was technological change. Okay? The green line here is investment, and it's useful to see that investment is a lot more volatile than that. Right? So the accumulation process seems almost as, notice that here investment for me matters because I'm going to talk about the way this increases in quantity, but also how it changes. And when it changes, that's not investment in national income accounting. It's something else. Sometimes it's depreciation because you throw it away. It's a lot of other things, but it's not net investment or gross investment. Okay, and you notice the gross tends to drop exactly in those phases we call recession. So the ambition of the project is to go after something like that. Even if what I'll present today is just a bit stylized, and I hope and next time, maybe together with Wang Yong, I'll present something with a different order. And a lot closer to that data, to that set of data and other data. But that's the story we are after, okay? So what am I going to do? To stylize things, I'm going to study a model with a representative agent. Growth theory is terrible from that point of view, but I think it's reasonable. One somehow implicit assumption of growth theory is preferences don't really matter. They're always the same in the long run. Now, I actually think it's true, but this is another talk, another paper, another time, but I actually think we should model it in a different way than the way we do. But for today, we just write the usual thing. So these guys care about consumption. They're all identical. They live forever, hundreds of years. They discount the future at rho, and it's a continuous time model. And then utility is the most trivial that there is. It's log of an aggregate. What is the aggregate? So the only thing you have to care is the aggregate. By the way, in the paper, there is old notation which I didn't have time to change because I wasn't sure I could change the test and the formula, so I left the notation unchanged. So you will find D's where I now have C, which is a lot more reasonable. It's consumption good. We always use C. And so at this time, having control of the file, I overruled my co-author that likes to invent special symbol. I said, no, David, we're not going to call that thing D anymore. Moreover, because we also call D the development deepening phase, and so people get confused, right? If you're using the same paper, the same lowercase letter to indicate two very different concepts, it's very easy to confuse people. So C is consumption. Consumption of time T which is a subscript there, but it's a continuous variable, okay? And in fact, I eliminate later, it's just later, it's always a type t, unless I specify otherwise, is a very different types. And the types here is just a very quick way. What have I done? Oh, so it's sensitive. If you
Yes,
get
it's
too
a-
close, it
yeah.
increases in size. Come on, baby, come down. No, not too much. Just be, all right. It's like a horse, you gotta learn to ride a horse.
Attain it, yeah.
You gotta tame it a bit. So consumption is a very different type, and this is going to be the simple way in which we represent technological progress. Okay? Lambda is a number larger than 1. J is an index, so lambda the power j increases with j. Okay? Gives you more utility, better goods. Now, obviously, this is a super simple way, but in fact, what I have in mind, as you will see in a moment, is to stress the. Okay, now it's a bit too much. Well, maybe I shouldn't touch it.
Yeah,
Everybody can see, right?
yeah, we can see it.
As I will show you in a moment, the proper interpretation is that this is fundamentally labor-saving technology. So the analytical way of representing it doesn't really matter. I could write there, eliminate the lambda, and just write a constant consumption without j, and use 1 over lambda in a production function I'll show you in a moment, and the result would be the same. It's just that I write it there and I forget forever, and everything becomes simple. Okay? So the first thing is that nature offers us a technology ladder which has these steps. You can improve things by walking up the ladder step after step. This is something that has been used now since the days of solo vintage, and it's well understood. You know, we've been using it for 50 years. Maybe it's not a big contribution, but an analytical tool we use here, and which is important, is a technology step is actually a combination of things. It is knowledge capital, which we denote by Kj, and again, this is a stylized model, but when I think at Kj, if I had to write an empirical model that wants to understand China, for example, I would say this is made up of at least 3 things. It's made up of specific machines that embody specific technology. You know, the assembly plant has very different ways of embodying technologies until they're robotized one of these days. It has to do with a set of knowledge, okay, that is more or less shared and embodied in engineer and books, routine, software, whatever, a set of knowledge. And a third element, which is the skill of the workers. And again, there is a distribution in reality, but we do understand that the workers operating an assembly plant that is being fully robotized are very different, are very different inputs in our dry language than the workers that were assembling the first Audi cars in this country 35 years ago. Very different, okay? And even more different from those that were assembling the Audi car in Germany in 1960 or 1955. Okay, as the plant changed, there is as the machines and their combination changed, the knowledge inside them changed as well, the workers change as well, and the product change. Okay, and so that's why a step in the ladder is both, in this simplified model, a type of capital or a type of productive capacity and a consumption good. It's enough to capture the fact that j plus 1 is better than j by purely using lambda larger than 1. So again, you can add all kind of other symbols, but it just confuses. Simple. One is better than the other. And lambda measures how much better. But they are specific. So if you want to produce consumption of type j, you need capital of type j. Okay? Capital, or KC, knowledge capital as we call it, or productive capacity, once it's there, it's a physical amount. It's a bunch of factories, people, stuff that goes together that can do things. Okay? And they can do essentially 2 types of things. They can increase productive capacity, or they can increase produce consumption, okay, of their type. Now, what does it mean to have more knowledge capital? There is more productive capacity. Well, it means either you have more of this type, or you have some new type, right? Think of what we do here, or be doing myself, what we do in research teaching institution like ours. We actually do both, right? Right? We, forgive me, try to make copies of ourselves by teaching. That's what I'm trying to do right now. I'm trying to make a copy of myself. Right? I'm trying to share with you some thoughts, some thing I think is knowledge, useful knowledge. And I'm trying to see if, to the extent I get you convinced that the knowledge is useful, there is a copy. There is another person, actually, dozens of other people after this that can go in another place in the world and produce the same thing. Right? That's knowledge. And obviously that's what we do in the classroom when we explain the demand functions slope down and integrals integrate and are the opposite of taking derivative, things like that. Right? We make copies of ourselves. And we also try to make research and create something new. We try to create a new self. Every day we get a result, or we run a regression, or we find some statistics that we think are useful, we've actually created a new self. This is very well understood among economists. We call that human capital. Funny enough, the same people that do this go around theorizing that this is not true because ideas are public good and they don't require any of these things. All this effort that we put, this tremendous amount of resources that we put in both reproducing old ideas, some extremely old, all right? They've been around for thousands of years. And they should be public good that everybody knows and acquire for free. Instead, we put these hundreds of hours in teaching them, and also we put hundreds of hours in creating the new one and multiply. But that's the way my model works. It takes effort, it costs both to make copies of yourself and to make a new self. And in fact, to simplify, this is purely for mathematical analysis, but you gotta go in steps. In fact, I believe you can bypass steps. I think China development and any latecomer development is a good example of the fact that you can bypass a step. That you can go from step j minus 2 to j plus 3 all at once by making a little bit extra investment, but it's convenient. Right? So you can choose to develop in stages, but when you're way behind and there is a lot of stuff of more advanced types in front of you, then there are learning technologies that allows you to skip. Okay? That allows you to skip. And many developing countries that are now using very advanced technology to do things. There's nobody that knows how to produce dishwasher the way they produced that in 1960s in Sweden. I'm sure no engineer in China has ever considered that. China's gone from no dishwasher to 1990s or 2000 dishwasher. And the all intermediate steps in the dishwasher, I say dishwasher for say refrigerator or phone, phones, right, have been skipped, right? And that was convenient because there was a way to do that. In other things, that's not the case. There are cases in which you just have to go through. By the way, learning is one such thing. Math is one such thing. You cannot just become an algebraic topologist waking up in the morning without knowing the difference between 1 and 2. But anyhow, this is not essential to the analysis. That's all I'm saying. Okay, it is just a simplification. Now, symbols. KC can increase on type. How? Linearly. They call it AK, I call it BK. It's von Neumann. Okay? If you want a more of capital stock of type J, you just take some of it, you put it in the B production function, and it gives you B units of that tomorrow. Actually in a second, because it's continuous time. All right? B is larger than rho, which is your discount factor. We know that's necessary. This would be saving. Right? If there is only widening, we call that thing capital widening. By the way, this is to pay respect to a very old literature that none of you have obviously know, because as a classical example, you have skipped state J plus 2 or J minus 2 in the history of the theory of economic growth. But this was not good, because I invite you to go back and read that, because there is more in the old J's in the research on economic theory and economic growth than in the new J's. So at a certain point in the literature in the 60s, there was a big debate about, and 70s, widening and deepening. And we're using that terminology because it's appropriate. So widening means you just make copies of the capital that is. You have a factory, you make two factories, identical. Or you enlarge the factory, but pretty much with the same machinery. Okay? You just keep teaching your undergrads and your graduates, and you don't do research. All right? And that grows at a rate B. Okay? It's solo footnote 6. Okay? And as those that have taken my classes this week and last week have learned, it's John von Neumann, 1937. Okay, that's what it is. This is Joseph Schumpeter. You can get J plus 1 from J, and that requires A larger than 1 units of Kc. And A is a big number. In fact, it's even larger than lambda. Remember, the lambda was a unit of measure of how much a better good J plus 1 is with respect to J. So lambda is how much extra happiness, market value you get from the new good. And in fact, inventing the new good from the old one is really costly. So costly the lambda over A is less than 1. Okay, so this is a key assumption. He wants to point out that if it were not because we need it, we would never innovate. I'm sure there is a Chinese proverb about it, like the one about fishing that I asked Young a moment ago, that creation comes out of necessity. No? In Italian they say necessity stimulates your ingenuity. I don't know. You guys don't have a proverb about that? That could be interesting for an anthropologist. No way of saying that creativity comes out of need in Chinese? All right, we'll debate that next time. Do some research about it. I'm sure that there is somebody. Confucius must have said it one day or another. You just probably didn't read carefully that part of the book. All right, but this is a key thing. So deepening is a lot costlier than widening. Okay. In fact, wait. I have another. Yeah. So the implication of this is that lambda over A less than 1 obviously means the lambda over A is also less than B. Okay. So definitely at any given point in time, if you can go widening, you go widening. Right? Yeah. You don't. All right, resource constraint. Remember, so productive capacity has 3 uses: widening, deepening, consuming. They're mutually exclusive, which is an important assumption here. Not only physical machines, but also human machine, and in general, anything that has value is embodied. There is no such a thing as a disembodied productive unit. In fact, this is a game I've been playing for 30 years since a graduate student. I always ask people, show me the disembodied technological progress. I haven't found one example yet. I take suggestions at the end during the question and answer section. Everything that has value, this is a Schumpeter statement, is embodied. It wouldn't have value otherwise. Okay? So you can split your capital as you please. I've repeated. If you put it to produce consumption, it's a very simple rule. Again, nothing religious about that. You like to have a little bit of substitutability? Sure. Not infinite substitutability, though. And I'm not going to go into that, but that's for another argument. This is the way technologies are characterized. Technologies are characterized by fairly well-defined ratios between inputs. Actual technologies are like that. There is no such a thing as a technology that allows smooth substitution along the isoquant. When you move along the isoquant, you're actually moving from a technology to another. which is why we observe that in reality, even in front of shocks to price ratio, you don't move from here to here that rapidly. When the oil shock came, right, and it increased the price of energy, and so, this is energy, this is everything else, right? And the price ratio went from here to here. The technologies took many years to go from there to move between the 2 points. One looks at the data, and one can see that when the second shock came 5 years later, they already started to move, but they were well far from where they eventually went. And they got there only maybe 15, 20 years later, when finally the price had actually, and this also caused the price to go down, okay? So that's what we're trying to capture here. This is the complicated equation, and that's the key. So how do you link the various motions? So as I said, if you want to widen, all you have to do is to put capital in there, right? Well, per se and theoretically, because capital is fungible, you might have some capital of the old type, right, that is not being used for producing consumption or for widening itself, but is being used for doing research, so to speak, or creating, trying to find new ways of producing things. If that's the case, that divided A, which is the cost of innovation, will also increase the stock of J. Now, obviously, one thing we will do in the thing is to show that you never do these two things simultaneously. But that's equilibrium. Per se, you could. And in fact, you could even do something funny, which means you could be transforming directly capital that you wanted to use for development into capital that instead you use for production at this period. We allow for instantaneous jumps. In particular, we allow this. We allow for a discrete amount of existing, a whole plant, 600 people, 6,000 people, 1 million people, with a certain kind of knowledge to be taken away from production, consumption, and teaching and be put straight into research. So we allow for discontinuous jumps, okay? And then we go solve for the equilibrium. So what's the property of this economy? It's a standard diminishing return economy. The technologies are linear or fixed coefficient, they're constant return, but there is decreasing return. Why? Because one factor, labor, is constant. So once you hit that constraint, you have diminishing return. You go flat. So the production functions here with respect to labor are all like this, right? And then they go flat. Okay? That's enough. It's the minimum amount of decreasing return you need to put, but it's enough for the abstract story and why putting more. Nothing of what I'm saying today would change if you put your usual smooth production function in here. You can put them in and it's all fine. Okay?
So, Kelly, could you go to the previous slide? So this one. So is it allowed that you also could have j minus 2 and divide by a squared? You like a 2?
Yes, it is. That's a good point. We show that this never happens.
Okay.
But per se, you could have all these things there that you left there, you never transformed, and you wait. The point is that it's kind of intuitive that you wouldn't do it because it's idle. Why leaving something that has value idle, right? If it is there, and I can instantaneously transform in j minus 1, well, let me transform in j minus 1, right? Which I can then use. There's no reason to leave something idle for a unit of time and then say, I'll transform it square later on. It's uneconomical. But yes, per se, technologically, you could do it.
But you just assume that you have to go through all these steps, right?
Right, but if I said square,
Oh, I see. But
you said square.
But I thought that you have to go by step.
Yeah, but it's instantaneous.
Okay.
Remember, it's a continuous time.
But you have to have the j.
But you
plus
lose a
1
lot,
first.
huh? It's square, the a, and a is a number
I know,
larger than 1.
But
yeah.
you have to have the j plus j minus 1 first to get j, right? You didn't assume that?
Yes.
This one is correct, right? Young is talking about another equation. You can say you can accumulate, you can deepen the capital J using capital J minus 1, but you can simultaneously, you can also accumulate J minus 1 with J minus 2.
Yes.
So,
And then from there you can go to J.
Yeah, but that's different. That's two equations, right? But Young was saying
Well,
that.
yeah. But this goes to the mathematics of continuous time, right? Both things are.
So that's.
Both gives me two derivatives, right? Strictly I would have k dot j minus 1 equal k d j minus 2 over a. But I don't have a delay, so I have a stock variation. See what I mean? My stock of j minus 1 is increasing at a rate 1 over a.
And how this is a starter point, just for him.
I don't know if I could write that. I know that I could do it. And now, actually, one thing we show, as you will see in a moment, the reason why I'm posing it is that it turns out that from purely as an equilibrium outcome, you never do this thing instantaneously, and you will see why in a moment. And the reason is that A is larger than lambda.
Right.
So you always accumulate at least a finite, strictly positive amount of the new capital before starting to use it in production. But that's only for the production of the consumption good. Okay, it's a technical issue, it's not very important. We'll talk about that later, because I noticed that the time is moving. All right, so it's a diminishing return economy. The new technology is better than the old one, because lambda is larger than 1, but it's also costlier, because A is bigger than lambda. Okay? Widening is profitable, so you do it in equilibrium. And cheaper than deepening, because B is larger than lambda over A. Okay? And the story I'm going to tell you is this. Growth comes from the fact that new productive capacity replaces old productive capacity. That's the creative distraction. Basically, the way you want to imagine, the stage I'll show you in a moment, is factories, with old technology are being abandoned and shut down. New shiny factory, it's China. New shiny factories with new technology are being built, and workers in the morning start going progressively to the new factory. Okay? So labor moves from old factory to new factory, that's creative distraction. And this takes place in cycles. How? Like this. This is the prediction of the model. So here is how aggregate consumption grows. It grows up for a period, then it goes flat, then it goes up, then it goes flat. Okay? This is aggregate. So remember, it's lambda times C1 plus lambda to the power 2 C2 plus lambda to the power 3 C3, that in this case is J plus 1, J plus 2. Okay? And what are they doing? So this is the contributor consumption of type 1, or J. Right? So the blue is aggregate. It's the sum of these. These are three lines. One is red, one is green, and the other is bluette. Maybe we should make them better. I always complain with my collaborator that they use these these light colors, and then I make the same mistake myself. Okay? These are specific parameter values that you can see here. Okay? So this is what's going on here. Here, the economy is shifting from technology J to technology J plus 1. And it's growing because technology J plus 1 has already been invented. And in fact, you see at time 0, it starts with net positive production. It doesn't start from 0. One other way of thinking at these lines, these are actually workers, because with the unit of measure I've chosen, L is equal to C.
Right.
Okay? So workers employed in technology J are disappearing, and symmetrically they're going to work in the new factories, which are also being accumulated at the same speed by the B technology. Okay, so B here determines how fast this thing goes up.
Right.
Now everybody here is employed in J plus 1. So there's no way of growing, because the only productive capacity I have is J plus 1. Everybody's employed in J plus 1. This economy is at what we would call a steady state. Okay? There was no innovation. This is an economy that stops, becomes stationary. And so for a while, there is no growth. As I will show, they are taking some of the KJ plus 1 capital, because we have J plus 1. And they're using it in that A technology to create J plus 2 capital.
Right.
But they're not putting it immediately into production. So here, in this moment here, times 0.6, right? A small amount is being created by the A equation. But it doesn't get immediately into consumption. The intuition is simple. Let me give it to you right away. What's the opportunity, what's the cost of that new capital in units of J plus 1? It's A, right? Because I got it already.
A, yeah.
And right now, what's the price of consumption, again, in terms of J plus 1 capital? Lambda, right? Because it's being produced, the last technology was J, this one is J plus 1, so a unit of J plus 1 gets lambda consumption unit. Lambda is less than A. Under competition, somebody that does that would make a loss. You don't start an activity where it makes a loss. So you have to build up enough of that capital that its price drops to lambda. And when the price drops to lambda, its opportunity cost drops to lambda, in competitive equilibrium is the same, then you put it into production because you make zero profit. This is a linear economy with perfect competition. There is no positive profit, but certainly there is no negative profit. Nobody carries out an activity that has no. So it's a zero profit condition you want to use. You always write less or equal, but you know that less means we just don't move, all right? So that's the logic here. It's the details of the algebra are there, and in fact we use that to compute how long this interval of time is. And I'll get to that in a moment. Okay. But we use the condition. Right? So it's a fascinating thing because I swear to God the model was not written with this in mind, and in fact we didn't say it at the beginning. So we did not expect this thing to happen. We expected a
continuous.
Right. And instead, we got that. All right?
But,
then, here it starts again. It's like here. Because now, finally, they put J plus 2 into production or consumption. And therefore, as you notice, it starts also at a strictly positive level. During this interval of time, that much productive capacity was accumulated of the new type. Mm-hmm. They don't start with an infinitesimal factory. They start with a positive size factory. Right? I don't start with a new university with one guy. If I start a university, I use the one guy I have that knows quantum mechanics to train other 7 guys that know quantum mechanics. And when I have 8 good guys that know quantum mechanics, I'll open up a university and say, this is the Chinese Institute for Quantum Mechanics. We accept undergrads. But until I have this kind of minimum size that is endogenous and depends on the parameter, depends on beta, lambda, everything. Okay, sorry, beta, B. Okay, I don't start production. At this point I start production, well, and you see what happens, right? The production, same thing. We phase out workers from the red technology. We put workers in the blue-red technology until we get again to another steady state. Okay? And then the story continues. It's not a very interesting cycle. When I was young, I was trying to generate chaos out of economic model where cycles were very complicated. Now I suffice with period 2 cycles, even boring ones, because one period they just do nothing. All right. This is the stock of capital. But I already described it to you, so there's no.
So I still, so this is about equilibrium path, right?
That's the equilibrium. I'm describing you the equilibrium path.
So then for this Euler, you have the log accuracy. So you want to smooth your consumption, but in equilibrium still have that stagnation where consumption growth rate is 0.
It's my specialty.
Right. So
I can make that thing extremely short by making this guy very, very, very. Oh, let me remember. Patient. No, but so well, everything depends on the distance between B and rho. Because when the distance between B and rho is the larger is the distance between B and rho, the faster you grow during the growth period, which also means the more you stagnate.
But suppose think about it like a more general CRA utility function where you wanted to make the intertemporal substitution elasticity sufficiently low. So you really want to smooth it.
You can certainly smooth it. You will have very small flats. In fact, this one has very big flats, as you know. These parameters are chosen in such a way that this is very big flat. In fact, the distance between B and rho is big, right? It's 0.7. Right, so you can.
Okay. So in my model with Justin and Jiandong there, we do not have this flat because all the technology are free.
They're free, yeah.
So you never get this, but you have the flat because the production of new vintage is just costly and
because the production of vintage is costlier. It's not only costly; it has to be. On the other hand, in a model like this were example we had in the old papers. If production new vintages is less costly than reproduction, so we show that a limit case of this is the one, in fact, in which the flat goes away. That's solo TFP. We can get the continuous thing. We just have to make A converge to lambda.
I see.
At A equal lambda, so A equal lambda is your case.
Nice.
And then it looks like this is a TFP model in the sense that it goes in the balance growth path.
I see.
Yeah. So it's actually there. I think it's in the appendix. When A equal lambda, that thing disappears.
So what happens to the investment? Do they?
They put immediately into production, even in infinitesimal quantity. Because at that point, the opportunity cost is the same. As soon as you have a fragment of the new technology, given that its opportunity cost is A, and A is equal to lambda, then it's also competitive to produce consumption. And at that point, for the reason Young says, consumption smoothing, this is an impatient individual, so he wants to have as much consumption smoothing as possible. Sorry, this is a concave individual, not an impatient. I misused the word really there. Is a concave utility individual. He doesn't want to have periods of high growing consumption, period of flat consumption. He wants to have it as smooth as possible, right? So he wants to always grow at the same rate. And at that point, they put the infinitesimal amount into that. One thing with infinitesimal is that we can divide them by 2 and they're still infinitesimal. And they're still positive, so that's the trick, obviously. Mathematically speaking, that's the trick. One here has to be smart enough to understand, to take the models seriously, but not religiously. Right? Obviously, there's not such a thing as an infinitesimal plant, and even less an infinitesimal plant divided 2. But the intuition is that, as soon as you have a minimum amount, you just put it into production, and you don't stay there accumulating the new technology. But if A is larger than lambda, then you wait.
And here you restrict the parameters such that in equilibrium you never have like strictly positive KT J minus 1 to produce J
Yeah, you do.
you
So here, so let me show you.
Could you
Let's
go
go
back to the
data.
accumulation
So
part?
remember, in every stage, okay, look at the stock of capital, right?
Yeah.
Remember, the blue is J, okay? The green is J plus 1, and the red is J plus 2.
Okay.
So there is no J plus 2,
Right.
0, while J and J plus 1 are active.
Right.
There is never more than 2 things in that. By the way, this is true because, okay, let me be very clear on this. This is actually something I teach in class often because this is purely due to the linearity. With decreasing return in the sense of if you add entrepreneurial factors or some other fixed factor to the economy, right, beside labor, and so there is decreasing return in K, then you can have as many as you want. Because in the margin, all you're doing is putting into production, we know how it works, right? We have into production all kind of capital that have a value at which their margin productivity is equal. So if I have 72, one I may be using a little amount, and one that is very productive, I'm using a very large amount. But as long as the marginal product, after all, it's Lucas' theory of the size of the firm, right? I just have a bunch of fixed factors, they're different. she's better than me, so his plant is 3 times mine, but his marginal productivity is 3 is equal to my marginal productivity at 1. I'm in business if there is demand. Okay? And so you can do that here too if you want to have a heterogeneous firms. Obviously, then you have to put up with the mathematics, but you can do it. So instead, here because of the linearity, only 2. And so you see what's happening, right? They're phasing out the blue, they're phasing in this,
Yes,
right? And then
in this,
they go through the period, right? Here they're innovating, they're finishing. No, this is a total stock. Please be careful. Look how many units, right? We go to 9 units of stock, even if in the production or consumption I'm using only 1 unit. So with this parameter value, this is an economy that accumulates a lot in the R&D, research, and investment sector. The production sector is just size 1, which in fact at that point is all that is left, right? Everything else is used to accumulate capacity. But this is because this is actually, with the extreme parameter you choose, this is an economy, this is China. This is really super China. This is the fastest growing province of China because the difference between B and rho is 0.7. That's a gigantic number. So they grow like a bat, right? And in fact, look at the gigantic drop, right? As soon as, this is all the investment plan being shut down, as soon as the new technology gets into production or consumption, and then this is the consumption that gets phased out, and they're shut down, but they're turning to the new one. So the ratio between this declining here is 8, okay? This is 4.
yeah.
The ratio is 2,
Oh, I see.
right? No, the 2 things are linked, right? I got all this stuff that I set aside to innovate. It's time to innovate and put stuff into production. Bang! Right? They all go into the new plant, and how many units are there? Well, half, because the conversion ratio is 2. So from 8 units, I go to 4 units. 8 units of the old turn into 4 units of the new. Okay, and the 4 units of the new, 3 are used to accumulate. Right? So they accumulate at a rate of x 0.7.
Okay.
So it's 3 at the x 0.7, the growth rate here, and 1 instead is put into there.
So when vintage J capital is used to produce vintage J plus 1 capital, then the vintage J capital is 100% depreciated. Is that his assumption?
Yeah.
Yeah.
When you turn, you turn.
You
Yeah.
turned it,
Yeah.
Okay.
Yeah, you disappear.
You
Basically,
disappear.
You and I stay one night,
Right.
figure out the theorem. We're no longer the same human being in the morning after. We are older, weaker, tired, and that's the A. And but we're also, the past is gone forever. There is no recall.
But given that,
If you really want to keep it, you can put it actually in the model, but it would be, you can put some, obviously, right? You can
I see.
always
I see.
leave it, the old factory there. You can decompose, one thing is you decompose the K, which is a union of humans and machines. You just throw away the machine. That's something we will have to do in our project. So we have the big depreciation, and instead you take the manager, the workers, and the technology in the new plant.
But okay, so maybe I'm slow here. So then because you have continuous time changes.
Mhm. Yeah, but remember, we allow for discrete.
The output is discrete, but the capital.
No, also variation in capital. That was the thing I wrote before, right? Which is essential because actually in equilibrium, it turns out you do that.
Yeah. So my question is, given this function, so in limit, that when vintage go up J2, J3, J plus 1, J plus 2, then vintage Kj in the limit could go to 0, but never 0. It is always positive.
No.
Or no?
No, so remember that there are 2 processes. So let me give them. So look at this process, right? Let's take the green. In the green here is going up instantaneously at 0 of an amount of how much? 3 something unit. Why? Because there was stuff J minus 1 accumulated. They got divided by A and became J. So J appeared and said there is 4 and something of us. Okay? Okay? Notice that in that specific moment, the 4 and something of them, none of them was producing consumption.
True.
They were, after a while,
Yeah,
it's
yeah,
continuous
yeah.
time,
Yeah.
right?
Yeah.
The stock of J started growing at the rate B,
Right.
actually, right?
Expand. Yeah.
And of that stock, a small part was put into here to replace this, because this was started to be phased out,
Right.
right?
Right.
So this is phased out and turned into J, and new J gets to employ the workers here, okay? So J now is growing for 2 reasons. A small reason, this stuff is being phased out,
Right.
right? So this, for a discrete amount, you go the vertical distance, the vertical drop divided A is the vertical contribution to the vertical
Plus one.
increase here.
Yeah, yeah, yeah.
But this is also using its own B production to accumulate itself.
Right. Two process.
Yeah, yeah, the two
together.
process.
Yeah.
So this grows.
Yeah. Yeah.
This is done at a certain point. They're done. This goes at its own rate, and this whole part here, this whole accumulation here, Yeah.
Is widening.
right? It's
producing
construct.
by
It's
its
to
own.
prepare
Yeah, yeah,
exactly for the new state.
But then the stock can jump.
Yeah, that's what it does.
So,
it here.
so can
Right
jump
here,
is
there is a
continuously.
gigantic stock, and they leave only 1 unit to produce consumption, so consumption doesn't drop. But all this, they turn it into the red thing. That's why here it's exact, because it's 9 minus 1, 8, divided to 4. Okay, so that's the process. Basically, this is it. I mean, I'm happy to stay here. The rest are just comments. This is actually how we solve. It's this, but this is in equation what I just showed you in a graph, right? Remember the unit of measure, so there's always full employment. So actually, in the paper, we also look what happens. In fact, that was a good idea of David. He said, to understand, we better start from the case in which there is no full employment. So, it stays, let's start from the case. If you want to use it, I think, Bo, you have this, I might have been pushing this on you time ago when we were talking about China and the thing. You can start from a situation which there is a army, proletarian army, reserve proletarian army, whatever it was called, in the countryside, that have opportunity cost essentially at 0, that's their productivity. And you don't have enough plants in the urban sector to employ all of them, and you just build up the plants, and people progressively come in. In that stage, they just come in, and their reservation wage is the survival reservation wage they have in the countryside, and at that point, you just accumulate. Obviously, you don't bother at all to innovate. Right? So we studied that in the paper. I skip it here, but it's fairly intuitive. At a certain point, you're always like that. Some guys are employed to produce consumption with the old plant. Some guys are employed to produce consumption with the new plant. Okay? And because it grows at that rate, you derive that from the first order condition. When is that you innovate only when you reach this stage. Right? Remember, the KC is the stock of, is the share, is the fraction of the stock of capital type J that is used to produce consumption.
And you need a B larger than J, larger than lambda, because technically that'll give you step by step. Otherwise,
No, B larger than rho to grow.
To grow, but a B larger than lambda, so that it can go step by step.
B larger than lambda over A because because otherwise
you would
right.
immediately jump to the highest.
You keep you would always have a microscopic fraction of each technology just keep growing like there is TFP. Essentially, So here is how it's computed. So you look at the phase, you start from here, and this is the initial position. Nobody works in the new technology. Everybody works in the old plant. At the end, it has to be the opposite, right? That everybody is in the new plant.
Right.
So consumption is at any given point in time in this phase is like that, total consumption, and you just write the differential equation there. Sorry, and then you set. It's algebra. Okay. The good point is just plain algebra. You have an initial condition, you have a final condition, you have a differential equation. You have 2 parameters. You figure out what the time. You have a distance to travel and you have a speed. Solve for the time it takes to do the trip. That's all that there is, right? And so, and this is the thing, right? So, and it makes sense, right? Because how long is this period? Well, it's obviously the bigger is lambda, the longer it is, and the bigger is beta minus rho, the shorter it is, because this is the speed at which I accumulate, right?
So tau g is the lifespan, sort of.
It's the
Is
tau g is the length of the time we go widening and consumption grows. Yeah, so that's the expansion.
That's the expansion period.
So we like this, but the initial version, instead of having the lambda in the utility function, we had lambda
Like
in the production
yeah,
function.
just have the same.
Because it's a good measure of labor saving. And the argument there, if
True.
you want, is
Right,
even
right,
more
right.
intuitive.
Yeah.
If I introduce a new technology
Yeah.
that saves a lot of workers, then that gives me a huge expansion.
Right.
Because I have a lot of guys to transfer to the new factory, right? If instead it gives me very little labor saving, then I don't have a huge expansion because I quickly employ everybody again.
Yeah, so actually, Jamie Perry, we have similar thing, exactly similar like that. And I suspect that in your model, if you instead of using log utility function, if you use CRA, say at the sigma, for example.
Well, then the sigma would
what
go
you
to the
have,
power.
Some parameter.
It would be
C.
lambda.
Yeah,
My
and
bet
then-
is that it's lambda over 1 over
Yeah,
sigma.
yeah. So basically, just a log lambda divided by this growth rate.
Yeah.
So here, your growth rate b minus rho over 1. That is your old equation
Right,
because of log.
right.
So if you have
Yeah. Yeah, the degree of curvature would go.
Yeah. Right. Yeah.
This is the other phase. And how you do here, well, you do the same, right? And here the question is, what's the amount of the new capital that you need to have to eliminate that thing I said before? So you have what's the amount of new capital you need to have so that zero profit condition is obtained and capital can be simultaneously used to reproduce itself and to produce consumption.
Right.
Until that is reached, you don't use it to produce consumption, so you don't start growing again.
Yeah.
Right. That's why for our project, it's some kind of cost of adjustment. Right? It's like,
You keep just producing your capital.
what's the point at which I start the new plant, and when do I stop training the new workers, preparing the new factory, getting the new engineer, doing the marketing, preparing the market for the new product, so I can hit the market.
Yeah.
Until I'm not ready to go, I'm not going to recover. So before I start producing the new whatever it is, before iPhone, what's the number they got? 72 million, whatever. Before iPhone J+1 gets into production, the appropriate amount of productive capacity has to be set up. I find that very, simple on one end, but realistic on the other. It seems to work like that. Right? They don't come out and says, "Oh, we can produce 3 iPhones. Who wants them?" Okay, and so it's another equation like that.
Yeah.
It's blah blah blah, and we compute. And so this is also very intuitive. How long is this recession phase or stagnation, whatever you want to call it, right?
Yeah.
It's, the cost here it is to innovate. Obviously, the longer it is,
Yeah.
right?
Right.
And the better the product is, the shorter it is. It's all. Yeah, it's one advantage of the log is that it makes almost trivial. But anyhow, I think everybody understands what the meaning of that is. That's it. So that's okay. So this actually I put it here in case there were questions, but you guys understood it right away. So it's this thing of A larger than lambda. I'm sorry, I couldn't. At some point I started talking to a student. I didn't have time to change fonts, so the symbol remains short.
We can see that.
Small,
Yeah.
but you can see. But I'm just repeating what I kept saying during the whole talk, right? And the point is here that the build-up phase. So the recession is a build-up phase.
Yeah.
That's the way we interpret it. Right? The recession here, the stagnation is a phase in which the economy throws away, uses all capital to try to create enough of the new capital that they can go back into business. All right? And it becomes profitable to do so. Right?
So
Obviously, there are many ways of interpreting this in reality. It could be that I'm doing improvement so that the opportunity cost is such that I can make profit. Because at the beginning, I have this procedure to make the new medicine or whatever it is, energy, but it's so expensive that there is no reason to go into a commercial production because, why do we subsidize the so-called alternative energy sources? We subsidize the so-called, in fact, this is one way of thinking at if it is worth or not, right, to subsidize alternative energy sources. And your remarks suggest that it might be if the discount factor, the degree of curvature of the typical market representative and the state official are different. I don't know if everybody understands that. So think about solar energy, right?
Yeah.
Solar energy, there is reason to argue that it's a more efficient way of producing electric energy than coal-based or gas and oil-based, okay? So the lambda between the two types of consumption is positive and larger than 1, right?
Yep.
Okay? But as of now, so solar energy is technology J plus 1.
Yeah.
Okay? Oil, standard electricity oil produced is technology J. But right now, the ratio between the two is lambda. What does it mean? In fact, it's 1, because at the end of the day, electricity it is. But let's assume that the consumer also factors in a bit of pollution. So the consumer is willing to pay 10% more for solar energy than for standard electric energy, but no more than 10%. Point is that the damn plants for producing solar energy are not efficient enough, and their opportunity cost of producing solar energy is 35%. And so if you put them into business in a competitive market without subsidies, they go broke. Right? So what you do? Well, you can do two things. One is you keep investing if you have a deep pocket and try to make solar energy efficient so that it actually compete at a 10% markup. Right. Or if you're an impatient politician that wants to get votes, you tax people and you subsidize it for the 25% difference, and so then now you sell solar energy at 10%, the other 25% comes from, right? Yeah. It seems to me it applies perfectly. That's what's going on, okay? Now the politician argument is, it may be true, we have colleagues that argue that it's huge learning by doing, and so it's worth doing. Then instead of just doing the research on the side, on the small scale, it's better to do it at a large scale, suffer the losses, because this accelerates the process. All right, but I mean, I don't know. I'm not expert enough to judge, but I have a way of thinking of it, and it's this. Okay.
So literally, in your model right now, when you by recession it means stagnation. So you do not have a strict decline output.
There is not.
Unless you have elastic supply labor or something.
Exactly. We need that, or we need some little shocks that make you lose. Well, there is the depreciation effort if you make losses. Yeah. But yeah, mine is strictly, that's why we call it growth cycle, because if you look, there is a literature, right, that says, you know, if the world is like that, and then I do this as a trend, then this is a recession and this is an expansion. Yep. So that's the trick. That's one case in which detrending helps constructing cycle, which, by the way, is the reason why I hate detrending, because it creates recession where there is actually something else. Mm-hmm. Right? But anyhow, our model is like that. Well, this is already obvious at this point, right? The model has no fixed cost. But if you look at this model, it follows from this, by the way. Right? So you can accumulate first and convert later, or you convert first and accumulate later. It's the same thing. Right? In either case, this is a way of turning something that costs A into something that costs lambda, because this amount, tau B, is exactly the amount of time at which 1 over 8 at the E at the B equal lambda. It was computed like that. Okay? And given that it's the same, it doesn't really matter. Meaning that the graph I showed you that showed first you accumulate the old type, and then you turn it dramatically into the new type, right? That, for example, as a description, doesn't work for the solar energy. Because for the solar energy, first you turn a small amount of the old type into the new type. Then you don't use it in production consumption, but you accumulate on the back burner for a long time. But it's already on the solar energy plant. And then it becomes good enough and you put it into consumption. But point is that it looks, if you look at this economy from outside, this is an economy with a fixed cost. Right? This is an economy with a fixed cost. Because what I see that there is a discrete jump. Right? And that's purely an equilibrium outcome. Nothing to do with the technology. Right? Here's the description. Right? You can go this and then put it all here, or you can go this. It's the same thing. Those are my calculations. All right, so these are the properties. I think they're clear.
But yeah, as
Please.
you said, it's a maybe equivalent long accumulation versus large operating, and but it will influence dramatically the measure of the cycle in the reality.
No.
No.
No, the consumption cycle is the cycle is completely identical.
You mean
Right? If you price them at their price, is the same. Consumption is always the same, no matter. And the conversion rate between the two types of capital is, in any case, determined by A, and then it declines toward lambda. And so if I look at market prices output, that doesn't change.
You mean only the substitution between widening and deepening, then the consumption.
The only thing that changes is what you see, basically. It's basically what you see. In one case, you don't see the upper red line, right? And in the other case, you see.
Just the long
Right.
layers like that,
Right.
and all more fluent like.
But consumption doesn't change at all. So let me go back to the old graphs, and I show you. I should have done. So actually, that's a good question. Next time I present it, I will construct another graph like this. So this is a graph in which, right, you convert at the end.
Right.
So this is E at the power B tau B times 1 over A. Right? So first I accumulate, and then boom, everything becomes J plus 1. Right? And so you see, I have a lot of J capital. Actually, well, in my notation it's J plus 1 capital, and I turn it into J plus 2 capital, all at once. I could have done the opposite, right? I could have turned a small amount here, so I would have had a little jump of the red, and I could have grown the red from somewhere here to here, and then I would have not seen this gigantic growth of the green. In that case, I would have done 1 over A times E at the power B T tau B. But the output of this economy is the same because there's always a price at which I can convert stock output of capital of type J plus 1 into market value of capital of type J plus 2 and vice versa. So the consumption, the amount in consumption is always the same, so consumption flow does not change. It actually shows that accounting convention are misleading, right? Because remember, in this case, you can call, I don't know how you want to call it, one of the two you call it R&D, in accounting identity. And in the other you call it investment. Point is that I can do something classified as R&D at the beginning in small amount, then do a lot of investment, or I can do a lot of investment for it, and then I do a gigantic amount of R&D for a short time, and the result is the same.
So is it true that in terms of the equilibrium wage rate, it is like a constant here,
The equilibrium wage,
and
yeah.
jump, like at
The
this
equilibrium
point?
wage is always determined by, remember the labor is employed only there.
Yeah. So the wage gonna
Lambda.
change it discontinuously at this point, right? So when you have two, then this is smooth. And even for this period, you only have one technology.
That's a good question.
And also constant. I think the wage rate is gonna just jump when you when
There is
first
inelastic
time when
labor
you-
supply, so the wage is going to jump.
the wage is gonna jump only at the point when
Measuring
the
units
new
of
technology.
abstract consumption, yeah. Because now it's worth lambda times the previous one.
Right. So which means then the labor.
No, wait. Maybe I think you're right, but I need to check because wage here is the productivity of labor,
Yeah,
which is
the
one
lambda j.
multiplied marginal utility consumption, which is 1 over lambda c times lambda.
So the aggregate C is the numerator, for example. Then the wage is always equal to lambda. Suppose you use j plus 1 to produce, then it's lambda raised to the power j plus 1. Why j plus
Well,
1?
because remember that during the transition, my consumption is
Yeah, I know.
where these are two numbers between 0 and 1, right?
Yeah,
That's the
yeah,
two fractions.
But the endogenous aggregate production function here, they're kind of linear.
Right.
So the linear function of L and the margin per
Right.
labor
So
is
this is
constant.
actually, we can write it as labor,
Yeah.
it's the same thing. Right?
Yeah.
So the productivity of labor is 1 over aggregate C, right, that's marginal utility, times year, lambda, well, a weighted average of these two, right?
Yeah, I believe this constant.
Yeah, let's check that, that's a good
Okay,
question.
yeah.
That's a good question. All right, I'm coming to the end, and so let me actually summarize here. The fixed cost property, well, I think these are all clear now. Growth and cycle are endogenous. Growth cycle bring about changes in factor share. Growth and cycle have the same cause, innovation. Innovation has a simple cause, decreasing returns. Some fixed factor somewhere hits you. There is no fixed cost to innovate, but equilibrium look like there is a fixed cost. And thank you. I'm done. There are detailed questions, but I think I exhausted my welcome, as they say.
I guess we still have two minutes. If any questions.
I just wonder, still based on my confusion just now, that maybe the indifference between any fixed cost or zero fixed cost, maybe that also it only influences the time or the frequency of upgrading because of that the three partition of capital in your story, but the different usage of capital are priced exactly the same in the society. Am I right? So maybe I'm not sure. For example, innovative capital and deepening capital and widening capital may be regarded differently by the public. Maybe then it will be resulting in a different setting of the fixed cost in innovation to the length of the recession in the modeling. I'm not sure whether I
Yeah, but I'm not sure I understand what you're asking. So, I know for sure because it's mathematics that if I compute at equilibrium prices total output, it doesn't matter. It doesn't matter that when.
Yeah.
In fact, remember they can actually. So here is one thing which actually I think we had some notes about this because we realized that there might be sunspots equilibria here if one complicates things. One has to put agent. Given that, look at that equation I wrote, right? This, right?
Yeah.
Well, you do understand that there might be other equations that I can write like that, right? Because this has assumed that there is a unit I'm turning. But hey, I can turn epsilon and grow that for a bit, and then I can turn another, right? I can do a lot of, right?
Yeah.
I can,
Is it determined?
given the things are divisible in this economy from a mathematical point of view, and it's mathematical curiosity, but there is an optimal amount that I turn either here or there, here we normalize it to a unit, right? Into the other thing. Well, why not splitting that optimal amount in 7 different parts and turning them at 7 different moments so the economy has all these jumps, that is like, right? Capital of the new type appears
Yeah.
in you see what I mean?
Yeah.
Consumption keeps being the same, but the new plants are appearing, and then they keep increasing themselves. So it's like, oh, Mazda, whatever, the solar plant Number 2 has appeared in the Hunan province, but it's not producing electricity, but the workers there are still extending the size of the plant. Okay? And then 6 months later, another plant in another province pops up and it keeps doing the same thing. And eventually, all of them together, at different sizes, get into production of electricity. So you can, I'm sure that this is possible. It follows from that,
So,
right?
so in terms of the
You see, that market value has to be the same if computed at the right price. It's true that if you have different subjective prices, then yes, you get different values.
right.
Sorry, I don't want to monopolize the other time, but I really curious about, for example, the setting. I'm not sure. So, like one standard economy like that. So, in fact, you mentioned that the innovative and the destruction and the Schumpeter's spirit in that. So I just wonder, for example, if facing, I mean that the leader and the follower in the war, maybe in a different process of this, call it later setting. For example, about the difference between A and lambda. For example, if the first mover in the frontier maybe follow your model, but the second, the follower, maybe A can be, for example, lowering by a follower in the world economy, and maybe I'm not sure.
Yeah, because they use B.
Yeah, they use B, and I'm not sure whether A will reduce its conversion.
You're asking me something that goes way beyond the model. Sorry, but again, the model is good for doing one thing: to capture the fact that inventing something is more time-consuming than making copies.
Oh yeah.
As we all know.
Yeah.
Right.
I
So we invent only one we need.
maybe
Right.
I just in short I wonder that the different kind of development stages may be resulting in for example the different A and lambda, where it represents different recession types around.
It's another model. Somebody has to write it.
Okay.
It's another model.
Okay. Thank you.
Thanks.
Okay, so we are we're behind the schedule.
Yeah,
So
more than welcome, overcome my welcome.
so thank you very much again.
Thanks.